Welcome to lesson 5 of unit 2. This one we're going to work on using scatter plots, drawing and using scatter plots. So this is going to be a pretty short video. We're going to be using graphing technology to draw our scatter plots on our graphing calculators. And then we're going to be calculating a line of best fit, which is also called a linear regression. Fancy words. So first of all, we need to learn about scatter plots. So data that has two different variables are called bivariate data, and a set of ordered pairs graphed in the coordinate plane is called a scatter plot. And the more closely the data can be represented by a line, the stronger the correlation. So those are vocabulary words that you need to understand and be able to use. So in this first graph down here, this has a positive slope, this line right here. So this shows a positive correlation. This one shows a negative slope or a negative correlation. And this one is completely random, so it doesn't show any correlation at all. Those are our three conditions that we could come up with scatter plots. So scatter plots are useful when they give us some kind of a correlation between two variables. One of the things you need to remember is correlation does not prove causation, so one's not causing the other to happen, but it does help us to make some predictions. So sometimes we can approximate data using a line of best fit. That's also often called a prediction equation because it lets us predict one variable if we know the other one. To find a prediction equation, what we're going to do is just choose 2 points that look like they represent the data well. So I've got an example here for you with algae. It says a scatter plot shows data recording the amount of algae and the temperature of the water in various aquarium tanks. Draw a line of fit for the data and write a prediction equation. So what I did was I went ahead and I connected the first data point and the last one here because I think those looked pretty good. So I just drew a straight line through those. So I'm going to approximate what those points are. And I chose for my x variable in pounds here, I think I chose 0.8 or 0.9. Here it is right here, 0.9. And then that corresponded to about 9 on the temperature scale. And then over here I chose, I think it was 5.8, and I said that's approximately 32. Okay, your numbers might be different if you're estimating those, and that's totally fine. We're not all going to get the same answers on these. So to go ahead and write our equation, remember what we need to do is to go ahead and calculate the slope. And the slope is going to be the change in y over the change in x. So 32 minus 9, that's our x variable change, right? So here are our y variable change. Our y variables are right there. And then the x variables are in the denominator. So 32 minus 9 over 5.8 minus 0.9 gives us 23 over 4.9 or 4.7. So that is our slope. So now we can pick one of those data points to use with our slope, and we can use point slope form that we learned in our last lesson to write an equation. So I said y minus 9 is equal to 4.7 times x minus 0.9. Okay, so we're getting values, and very likely with real world data, you're not going to get nice integer numbers. So the next thing I'm going to do is I'm going to go ahead and distribute that 4.7 through the parentheses and add 9 to both sides. So 4.7 times 0.9, I didn't write that down in here, but I should have written that step in for you. And then when you add 9, you end up with 4.8. So this is called a prediction equation, and that basically says we can pick any value we want for the number of pounds of algae and calculate what the temperature would be in the water. So that's it, short and sweet for this video. We'll be doing most of this on the calculator, and I'll show you how to do that on the calculator in class. See you next time.